This is going to be a short video showing you how to do the review problems for Thursday's test. So these are the 7 review problems plus 1 from the group quiz that I'll go over at the end if I have time. Alright, if you read this problem, it gives you a bunch of information and it wants you to create a graph and an equation of temperature as a function of time in minutes. So the temperature is a function of time in minutes. Well, that tells you that the temperature is going to be your y and your time is going to be your x. So I know minutes is going to go on my x-axis and temperature will go on my y-axis. So let's see. I'm going to start off with reading this information. It's giving me the maximum, so let's look at the max. Is 125 degrees 15 minutes after they start. So it looks like after 15 minutes we have a temperature of 125. Then it says minimum of 99 degrees occurs 20 minutes later after the 15 minutes. That means my minimum, well, let's see, 28 minutes after the 15, I have to add that together, so that'd be 43 minutes. I'm going to have a minimum of 99 degrees. So there's my information for max and min. Now, the midline is going to be dealing with my y values. So the d value, to get the midline, the middle of those, I'm just going to add these together and divide by 2. And that'll give me 112. The amplitude is going to be the distance from 99 to 112 or 125 to 112. So I could tell that's 13, but you can also subtract and divide by 2. And get 13. The period, well, from max to min, that's half of a cycle. So if you look at my x values, the period is going to be double 43 minus 15. So really that's double 2 times 28, which is 56 minutes. So one cycle, it will take 56 minutes for one cycle to occur. So now let's get the information on my graph and then I'll write the equation. So it looks like my y values, dealing with, let's see, 112, 99, and 125. So this is not going to be real accurate. My highest is 125. I'll put that here. The middle is 112, and then the min is 99. So this will be good enough. Now the let's see, the minutes says 15 minutes, so I got 15 here. Well, if I know that the period is 56, if I divide that by 4, I get 14. So every 14 minutes I'm going to have one of those critical points. So 14 plus that is going to give me 29. 14 plus that will give me 43. 14 plus that will give me 57, and 14 plus that will give me 71. So that looks good enough. Now let's plot these points and see what I get. So max at 15 minutes, so there's my max. Let me draw my dotted line in. So let's see, dotted line for my 112. I always like to do that because that can be helpful with the graph. So let's see, scoot that up a little bit. Alright, at 29 I'm going to hit a critical point, which is my midline. Then at 43 is my min. 57 is another midline point, and then again I'm going to end on the max. So the graph is going to look something like this. And whoops, this is a rough sketch, but that's roughly what it looks like. Now the equation I can write several different ways. Most kids are going to feel comfortable writing it probably a cosine equation, so let's write it from here. So if I do start from the max, I already know the amplitude is 13 and it's positive because I'm starting from the max. Cosine, I'm going to write the period, which I found to be 56, so it's really going to be 2 pi over 56 and then my parentheses, and actually I could reduce that. X minus 15 plus 112. That's the midline value. So really that can be reduced, and I could write it like this. So if you know that the period is 56, then your B value, it's always going to be 2 pi over B, which equals the period. So really, I mean, if I know the period is 56 and the period is equal to 2 pi over B, then I can solve for B and write it as 2 pi over 56. So that's how I got the B value here. And then I reduced it. So that's my equation, and that's really my rough sketch. Alright, let's look at the next one. The next one talks about a water wheel. Rotates at 4 revolutions per minute. So 4 revolutions per 1 minute. Well, I want to know if it goes 4 revolutions per 1 minute. That's the same thing as 4 revolutions in 60 seconds. Well, if I reduce that, that's 1 revolution in 15 seconds. So that is the period. Period is the time it takes for it to go around one time. So the period is 15 seconds. Alright, so let's look at the other things that I need to come up with. So if the period is 15 seconds, the B value would be 2 pi over 30. And mainly I can do that the way I did the other problem. Oops, whoops, I meant 2 pi over 15. Okay, so that's how I can get B, by setting this equal to 2 pi over B. Alright, so now let's look at the other information. The diameter is 10. So I am going to put in the radius. That radius will be 5. And then it says that it's 1.5 feet submerged in water. So this much right here is 1.5, which means the rest of that has to be 3.5 because it's got a radius of 5. Alright, so let's see. If a point on the wheel starts at the greatest height, so that's going to start at the max, it wants the equation of this water wheel. So let's see if I can figure out the max. Well, the surface of the water is like 0, so I'm going to put 0 here. Now I know this middle point, I'm going 3.5 feet above the water, so there's my 3.5. And then the maximum, if you add the 5 and the 3.5, that's going to give you 8.5 feet. So these are my values. The minimum is underwater, so it'd be negative 1.5. So that's how I can get my min, max, and midline. So D is 3.5. My, let's look at A. A is going to be that distance in between. So the A value is going to be 5. Distance between max and min, that's just your radius. Your B, we already stated, 2 pi over 15, because the period was 15. And B is 2 pi over P. And we're starting at the max. So it looks like I have enough information to write my equation. So let's write my equation. Y equals, let's see, 5 cosine 2 pi over 15 x plus the midline D value 3.5. And that's what it appears to be, because it is starting from the greatest height. So that's how I know it started there. So that's a positive. Alright, so now let's look at, and that's all they wanted. Let's look at the next problem. The next problem I'm going to have to put in the calculator. So I've got different screens showing up of the calculator. And let's see, if I look at this, this tells me right here this tells me that my period is 342. But because is starting 80 units to the right, I'm going to add 80 to that. And that's going to give me my highest X value. So I actually picked 430 and went a little bit above that. Now for the min, you could just pick 0 here. And I picked a scale at 20 because it was pretty large, those numbers. For your min and max, let's see, there's my D and there's my A. So to get the max, I'm going to add D plus A. And for the min, I'm going to take D and subtract A. So that's how I chose these numbers, -10 and 22, which were rough estimates of these values. So there's my window, and then I'm just going to type it in, my y equals screen, which is shown here, except for the plus 6.8, kind of got cut off. And I'm going to pick a value where x is 105, and that would give me my answer. And I'm thinking, does it say what to round to? Well, I'll just do 18.6, because it really does not say. And does it give me, yeah, feet. So about 18.6 feet. Now the next part tells me, and again, it doesn't say round to the hundredth, so I mean this could vary, but what is the first time at height is 7? That part is here. So I simply type in y2 equals 7, and then here's where I do the second trace, and I go to intersection. I think it's number 5, and then I want to get to be about to where that point is and hit enter 3 times. So the answer is going to be about 164 point, well, it's either going to be 68, depending on how I round. I'll round this to the nearest hundred because I'm not sure what it's supposed to be, and that would be seconds. So that's your answer for number 3, and that's all calculator. Alright, now this number 4, it just tells me that the period is 8, so I know that. Well, that means every 8 units I'm going to get the same value. So if g of 0 is -3, then g of 8, which is 8 units away from 0, would also be -3. And that's your answer. I really did not need g of 4 to figure that out. Okay, number 5 says the first positive equation for this graph. So I graphed the reciprocal sine x, and I've got that shown. And then where that's 0, that's going to be your first positive asymptote. So your equation will be x equals pi. And that's the answer for number 5. Number 6 will give you, let's see, a graph that looks like this. The equation, tan, the period is going to be pi over 4. My starting point is 0.5, so I plot that here. Now I go halfway. Since this whole block is pi over 4, I want to go halfway. And that creates an asymptote in that direction, and halfway here creates another asymptote in that direction. And half of pi over 4 would be pi over 8, and this would of course be negative pi over 8. So once the greatest negative asymptote equation, that's x equals negative pi over 8. Alright, let's look at the last few problems. Alright, number 7, I've got my max and min, so I can get A by subtracting the y values and dividing by 2. So that's 3 over 2. I can get D by adding my y values and dividing by 2. So that's 7 over 2. I can get the period by looking at my x values. So the period is going to be 2 times this distance. So that's a distance of 5. So the period is 10. So my equation could look something like this. And B would equal 2 pi over 10, which is pi over 5. So your equation would be y equals, I'll just do a cosine starting at the max. So cosine pi over 5 x plus 3, because I'm using my max, and then the amplitude is 3 over 2. So that is the equation for 7.